Today's lesson is all about arithmetic and geometric series. An arithmetic series is the indicated sum of the terms of an arithmetic sequence. So I've given you two examples here, 4, 9, 14, 19. The commas separate the terms, so you know that this is an arithmetic sequence. Whereas 4 plus 9 plus 14 plus 19, the terms themselves are still in an arithmetic sequence, but because you are adding them together, this is called an arithmetic series. All right, given the first term, the last term, and the number of terms of an arithmetic series, so first term A, the last term Tn, and the number of terms, so n, the sum of the series can be found using this formula, Sn equals n times a plus Tn over 2. So you're multiplying the number of terms by the average of the first and the last terms. If you were to rewrite this equation using the general term formula for an arithmetic sequence, okay, so I'm replacing Tn with a plus n minus 1d, and you simplify, you end up getting that, okay, which turns into the second formula right below. So given the terms of the first terms of the arithmetic series, the sum of the first n terms can be found using this formula. So if you don't know what the last term is, but you know what the common difference is, then you should use this form. Okay, I'm going to box these formulas. Let's go over some examples. Determine the sum of the first 10 terms of an arithmetic series having a equals 2 and t10 equals 38. So because we want to know the sum of the first 10 terms, so we know n equals 10, and we're given a equals 2 and the last term in the sequence, then we can just use the formula Sn equals n a plus Tn over 2. So I'm going to sub in 10 for n. I'm going to sub in 2 for a and 38 for Tn. And the sum ends up being 200. So therefore, the sum of the first 10 terms of this series is 200. For example 2, determine the specified sum for each of these arithmetic series. So the 15th term for negative 12, minus 8, minus 4, etc. So we know that n equals 15. We don't know what the 15th term of this series is, but we do know that the common difference is 4, that we just have to keep adding 4 to get to the next term. So I'm going to use the second version of the arithmetic series formula. I'm going to plug in 15 for n, plug in negative 12 for a, and plug in 4 for d. All right, so just simplify, and you should end up getting 240 for the sum of the first 15 terms. All right, second example. N equals 20. We keep adding 9 m's, so that would be our common difference d. So Sn equals n over 2, 2a plus n minus 1d. So pause the video, try it on your own, come back for the full solutions. All right, and you should have gotten the sum of the first 20 terms as 1,490 m. All right, last example. Determine the common difference. So we want to find d if the sum of the first 7 terms in the series, arithmetic series, is negative 63, and the first term is 3. All right, so based on the given information, we're going to use the second formula to find d. So plug everything in, rearrange your equation to solve for d. Okay, so negative 18 minus 6 divided by 6 gives us d, and d equals 4. Done. Okay, we're at the top of page 2 of lesson 7.2. So a geometric series is the sum of the terms in a geometric sequence. So for example, -3, 6, -12, 24, that's a geometric sequence. The common ratio is -2. If you add those numbers together, so -3 plus 6 minus 12 plus 24, so on and so forth, that gives you a geometric series. There's just one formula for the sum of the terms in a geometric series, and that is Sn equals a bracket r to the power of n minus 1 divided by r minus 1. And the restriction on this, if you remember all the way back from Unit 1, rational expressions, r can't equal 1 because otherwise you'd be dividing your expression by 0. If r does equal 1, then your sequence would just be a plus so on and so forth. Okay, oops, sorry, I just wrote that one. In which case, you would just get the sum of the first n terms as a times n. Alright? So, next example. Determine the sum of the first 10 terms of the geometric series with a equals 5 and r equals 4. Substitute everything you know into your formula. Okay, and simplify. And your final answer should be 1,747,625. It's a big number. Alright, let's try the next example. Determine the sum of each geometric series. The first term is 32. The last term, you know, is 1 over 8. That's where the sequence ends. The common ratio is half. So, you're going to need to figure out how many terms there are in this sequence first. Sorry. So this is Tn equals ARn minus 1. Plug in 1 over 8 for Tn. Plug in 32 for A, half for R. Okay. Divide both sides by 32. 1 over 256 equals half to the power of n minus 1. 1 over 256 is half to the power of 8. You were using equal basis, remember from Unit 4. So 8 equals n minus 1, so n is equal to 9. So there are 9 terms in this series. Now you can use the sum formula and plug in everything you know. And you should end up getting 511 over 8. Try the next example on your own. Pause the video and then come back when you're done. Alright, the sum of the first 6 terms, for example B, is negative 182. And over here, this was the sum of the first 9 terms. Alright, last example. Determine the number of terms in a geometric series if the sum is negative 63. So Sn equals negative 63. The ratio is negative 2. R equals negative 2. And the first term is 3, so A equals 3. Alright, let's plug in everything we know. Sorry. Okay, multiply both sides by negative 3. And we also need to divide both sides by 3. 63 equals negative 2 in brackets to the power of n minus 1. Move the negative 1 to the other side. So you get 64, which could be rewritten as negative 2 to the power of 6. So therefore, n equals 6, and there are 6 terms in this series. And that's it.